So I guess I'm just curious, how does the an acidic compound actually break up? You're saying these sacks are specific alloys?
So no, what's inside of the sacks are nickel acids. So the solution is a nickel sulfate, but it's on the inside of these bags are solid nickel chunks. We're taking and pulling nickel ions off of the nickel that's in here and then applying it to the tank. Now there is nickel already in the tank that's dissolved in the supersaturated solution. And so this kind of replaces it as it goes. So there's nickel in the solution, solid nickel inside of here. This is your positive, and this part is your negative, so your anode and your cathode. We're going to pull nickel ions from here, and it's going to apply to the part, then coating the part with nickel.
That's unbelievable.
So it kind of replenishes itself as it goes, but you do have to add other chemicals to the tank if you are plating out. If you're plating it out faster than what it's rebuilding itself. So it replenishes itself to a point, and then you have to add if you exceed it.
Cool. That's awesome. Yeah, that made no sense to me because I'm like, acid, it must take away. But the whole process is actually plating all at once.
Yeah, the acid also acts as an electrolyte. It's what causes the reaction, helps carry the current.
And then you were also asking about the stirring.
Yeah. So yeah, why is it bubbling?
It's not boiling.
Yeah.
A lot of people see this and they think it's boiling.
Right.
It is a heated solution. Ranges from 110 to 140 degrees Fahrenheit.
Oh wow.
So it is heated,
But not.
but it isn't boiling. It's stirred with air, so it's air agitated.
Awesome.
All bubbling up from the bottom.
Just
That's air.
it moves the solution so that you got to imagine if the solution around and you're pulling stuff from that solution, if it just stays there, then nothing happens.
Right.
So this is moving it, causing new solution to be there, and so it agitates it, makes a pretty part, and it
Makes it pretty.
That's
Or nickely.
makes it nickely.
So this is nickel and that's copper?
Yes, this is nickel sulfate, and that is copper sulfate.
Yeah, dude.
And so it's the same
Why
concept.
don't you pull that one out?
Same exact process. This is copper sulfate. Inside of these bags here, they are called anode bags, are solid copper. So, and then this is what copper sulfate looks like. Well, what copper looks like out of a copper sulfate solution.
The amount of time that these are in
Hours.
Yeah.
So you got here early today and then gave him the stuff and then you already had it and you put it in the morning, Mike?
Yeah, so these parts will sit in here for hours, building up thousands of thousands of a microinch, and then Dan will take them, hone them.
Yep. Hopefully correctly.
Well, it's usually always correctly.
Good. Good.
Usually. I said usually. Usually is very vague.
Thanks, Mike. That's awesome. I really appreciate you explaining that to me.
There's a lot involved in this. He makes it sound really simple. Right? Yeah, but it's actually...
So what is what we have in these bags, you said, Mike?
So it's a copper phos anode.
Okay.
It's kind of hard to conceal. So they're like little nuggets. So inside is copper phosphorus material, and same thing that happens there. This is mainly what makes this one tick is sulfuric acid.
Oh, okay.
Sulfuric acid. So this one's a lot more acetic than that back over there.
So this is definitely like Coca-Cola Plus.
This one's Coca-Cola Plus.
Okay, word.
Yeah.
So that is phosphoric acid.
No, this is sulfuric.
Sulfuric, and this is phosphoric.
No.
Well, they're both sulfuric.
I mean, you can add sulfuric acid to that one, but it's mainly boric acid.
Boric acid. Oh, okay.
Boric, So this is copper sulfate, which is copper metal ions, copper sulfate, sulfuric acid, and mainly water.